Can you see that my shared screen?
Yes, sir.
Yes,
Okay,
sir.
thank you. So today we start at chapter 2, chapter 2, the second part. We are talk about the expect to talk about the memory. It's a little bit important. So memory consists with that electronic component that store the instructions waiting to be executed by the processor. Okay, that memory, there are different kind of memories. You know that mainly we can divide into two, primary and secondary. So in the primary, you can see that mainly that the RAM, and after that they have a cache memory, registers are there. So and secondary memory we call that is store the data in permanent. It may be a hard disk, it may be another device, a pen drive, whatever. So each location in memory has an address. That's the important thing. Each location has their own address. So otherwise, the computer, that the CPU cannot access. You know that a CPU central processing units have that a control unit. Control units send the signal to open this shell and read the data. Okay, so then there should be that memory address. Memory size commonly is measured by the gigabyte or terabyte. So less than that amount, they have a megabyte, kilobyte. So I think you know these things. So currently we are more, if you want to buy that some nowadays, the hard disk, they're asking what is your capacity in the GB. Oh, nowadays actually very recent, they have a terabytes also, TB, 10, 5, 20 also now. Okay, the operating system and other programs also running in that RAM. Applications are running in that RAM. So, and data being processed and the result information go to the memory. So these are the data handled by that memory. So system unit contain two of memories. This is talking about that there are technical features, volatile, non-volatile. Okay, what does it mean? The volatile loss its content when power is turned off. Example, include that RAM. Okay, so the second non-volatile memory. I will ask that some questions. These are very simple and small questions, but there may be in that exam paper. Does not, what is the non-volatile memory? Does not lose content when power is removed. That means we can save the data even they have no power. The example include that the ROM, flash memory, CMOS, and also hard disk, a tape type any records, we can say as it's a non-volatile. Volatile is mainly talk about that the RAM. Why it is a volatile? Why it is have like a permanent? Because we not use that every time. So when you turn on the computer, what happened? The operating system files are located in that C drive. They are retrieved to RAM and arrange the programming environment. Sorry, not a programming, the operating system environment in that RAM. Okay, so it's read the what are the available location of the data, and it's read the what are the applications available in, and you know, when you while you are installing that some application, they asking, do you need to put that icon in that desktop, or do you need to put that some short what you call that shortcuts in that your Windows bar. So these are they are preparing while you are login while you are switching on that your computer. So it take time. What that happened at that time, that all store data in that memory, the hard disk, the secondary memory, they are retrieved to memory, RAM. So it is not, it should not be keep the permanent. That's why it is used that a volatile memory for that RAM. Okay, so two main types, volatile memory, non-volatile. Volatile means loss its content when power is turned off. Then other type, that non-volatile, is not lost the content even they have no power. Okay, so the RAM. Here you can see that the left side there are different size of RAMs based on that your computer versions. The random access memory. The device allow data item to read or written almost the same amount of that irrespective of that physical location of that memory. That means it is depend on that the memory size, that physical location of that memory. So currently random access memory takes from that integrated circuit, IC, chipsets, and MOS, metal oxide semiconductors memory in there. That is their technology they use. Known as a main memory. Here you can see that some synonyms, the similar words. Known as a main memory, we are called this a main memory, temporary memory, cache memory, volatile memory. The operations read and write. Volatile, temporary store. Volatile means the temporary store. Okay. Two common types of the RAM chip. So statistic RAM and dynamic RAM. Okay, there are two types of RAMs. Here you can see that they are characteristic. Synchronous. This is another special one, but no need to worry about this specialization. You have to think. You have to keep in mind there's a two type of RAM: dynamic RAM, statistic RAM. But when you are reading some books, you will found this kind of words that mean additional type of DRAM, that is a synchronized dynamic RAM. Synchronized means that a system clock much faster than the DRAM. So they have some features. Here you can see DDR, DDR2, DDR3, DDR4. Because now I think most of computers use that DDR RAM. But have you heard about that statistic RAM? So why you want to get that screenshot? I upload this this lecture note into that LMS after that our lesson. So then I think no need to get the screenshot. Is it me? You can take that whole lecture note as a PDF format. Okay. Yes. So then we will first study about the statistic RAM. Statistic RAM is a type of semiconductor memory. Bits store as an on-off switch. We are using that flip-flop for that. We will learn what is the flip-flop later. No charge to leak. Here, with that, now we are talking about the statistic RAM. Okay, no charge to leak, no refreshing need when powered available, more complex constructions, more expensive, does not need refresh current. What is that? This is also volatile. Okay, keep in mind. So we can so can you upload this note before the lecture time? Okay. From the next, I think yes. I divide into two parts in that chapter 2. So then you couldn't get it. Yeah. I will do that. One of you asking to upload that lecture note before the start the usual lecture. Okay, I will do that from the next chapter or next day. Yes, no charge to leak. That's what's the mean? Here use that a semiconductor. If you use that like a capacitor, you know that they have a characteristic. It cannot keep that long time that value. It is short. It is leak. Okay. So that's why every time, if you don't know, we couldn't feel that if you use that DRAM, is done that frequently they have to give that some charging value, that power, to keep that, refresh that value. Okay, so that means they have some capacitor, they have that available semiconductors are discharging. They are not the semiconductor, they have used that capacitor. Okay, normally capacitor cannot keep the long time that value. You have to charge again, refresh. Okay, so statistic RAM here. Now go back to, okay, let's go back to again that the previous slides. Here we have two types. What are these? We talk about the RAM, random access memory. Random access memory is what? Random access memory is volatile. Okay, volatile. Volatile means if it is power of that memory, so that data will lost. Okay, the data will lost when power is turned off. Okay, this is a volatile. Example for the RAM. Okay, in the RAM we know two types. What are these? DRAM, dynamic RAM, and statistic RAM. Here, the meaning of that statistic means statics. That means it is keep that some permanent. Have you heard about that dynamic web page, statistic web page? Okay, statistic web page means we are not changing that every day. That dynamic web page, they are changing that daily time, daily weather, or some stock market's value. Every time it is changing. And the statistic like web means if you put that your biography in there, so it's not change every day. Okay, statistic mean that somehow permanent, not the long term. Okay, so in here they say that no charge to leak, so then it is not charge to leak, so then it is keep that say value in that for a long time. No replacing need, no need replace, because the reason need SRAM, statistic RAM uses semiconductor modules. So that's it's very complex and more expensive. Actually, I think some of you have that experience. I had that experience when I bought that my computer first time, in that after doing my A level. So I got this. I thought at that time that statistic RAM is very new things, and I didn't know that the technique behind there. So I bought. Unfortunately, what happened? It is very expensive, and when you want to replace again, that when you want to upgrade again, so it was very cost. At that time, I understood they have using that special technique. Okay, so then, but nowadays, most of you are using that DRAM, DDR. I think now, up to my knowledge, DDR4. I don't know DDR5, maybe DDR4. So now, did you get that point of that? Why it is mean that no change? Sorry, no charges to leak. Okay, so example, it is fast. Actually, this is what are the advantage? It is fast. It is say that a cache. Example is a cache memory. So then we are talking about the dynamic RAM. Semiconductor memory that store each bit of that data in that memory cell. Bit store that charge of the capacitor here. Bit store in that charge in the capacitor. So when you know that if you use that capacitor, it is leaking their charges or losing their charges. So when losing their charges, you have to refresh. Here, charge leak because of that nature of that capacitor need refreshing even when powered available. Even powered available, you have to give that some signal to refresh. Okay, simpler constructions, less expensive, slow. It is slow when compared to the SD RAM. It is, sorry, statistic RAM. that dynamic RAM is low. Essentially, analog. That means you can keep that some analog signal. Analog signal is like not. It is continuing charging and discharging, not like value 0, 1 like that. Level of charge determine the value. Main memory. Main memories are normally is that DRAM. Okay, so here you can see that the comparison of that SRAM versus DRAM. Both are volatile and dynamic cell. If you use that a dynamic cell, that means dynamic RAM, simple for build and smaller, less expensive, need refresh, large memory unit. When you go to that statistic RAM, faster. Example for that cache, SRAM is more smaller size. SRAM is costly than the DRAM. Key difference. DRAM is comparatively slow than the SRAM. And so it's take more time to access the data and information. So SRAM offer that low packaging density. That means SRAM is capacity is very low. The offer that low packaging density. That means you can use that much data. So DRAM offer that a high capacity density. So then it is, sorry, I give that wrong explanation. DRAM have more capacity. Okay, SRAM have a less capacity. DRAM needs refresh. I think now you can get. Keep in mind, this is important. I will ask that questions. So then we will move to that read-only memory. Wrong. Refer to that memory chip storing permanent data and instructions. Example, the flash memory. Flash memory can be erased electronically and rewrite. CMOS technology provide the high speed and consume little power. I think flash drive, you know, it is the CMOS also some kind of flash drive. That means it is come under that ROM, but different technique they are using. Here, read only memory. Here you can see permanent storage, non-volatile, microprogramming, library subroutines. That means they have a libraries, and that means they have functions. System program, BIOS. BIOS come under that ROM. Here you can see that left side. When you are booting, if you press F2 or F10, you can go to that BIOS settings. BIOS settings are permanent, but in that permanent, they have a value. Value may be changed. As example, if you plug that 8 GB RAM or 16 GB RAM, they will show that relevant value. The value may be changed, but the content, that the instructions are permanent. Okay. So read-only memory which contain the data required to boot up the computer system, the ROM. Okay. The BIOS. BIOS has each and every information about that your device, and it cannot be modified easily. Here we are the meaning of that word is say that a read-only memory. So the last sentence it is say that it can be modified. Sorry, it cannot be modified easily, or even sometimes not at all. Some ROMs we cannot modify, but they have a special versions. In that ROM is in that your main board. You can find out that where it is from. Okay, so some ROMs are not suitable to open to the direct to that sunlight or any other bright lights. It will be destroy that your program. Okay, that some kind of ROM. So then very carefully when you open that your PC to the light, so it cannot be modified, and even sometimes not at all. But the modern ROM can be erased or reprogrammed in some way. What are these? Here, PROM, the special type of ROM, written during the manufacture, very expensive, programmable ROM, need special equipment to program, read mostly. So these are the some special kind of ROMs. Okay, erasable, programmable ROM available, electrical erasable ROMs available, flash drive, erase whole memory electrically. That means the flash drive we are using normally to data sharing. So it is also type of ROM, but not like technique using that CMOS in that computer. Okay, so just read this and take that some idea. If you need more explanation, you can find it on the internet. Just Google it. Cache memory. So then we are moved to that very important type of memory, cache. Memory cache speed the processor of the computer because it is stored frequently and use instructions and data. So why we are using that cache? So I will ask that question. There may be this kind of question. Why they have a cache? Now we know that the two type of primary, secondary. Even though they have another type of cache. Why? What's the reason? Just give me that if you have some idea or if you have some experience, why they have cache? Here, it is give that some hint. Cache is speed. The to processor to access the data. So the RAM also is speed. Why? Actually, your CPU is processing speed very short. It is, we are talking about the nanosecond. So that, yes, what are the answers? Boot up then RAM speed to decrease the, yes, we can accept that your answers, but especially reason is CPU is very fast. Okay, we count that CPU processing speed in that a nanosecond. So that means it is need to quickly read the data, read the instructions, and save the data back. So we cannot directly that the CPU can directly access the data from that RAM, but it took time. Okay, so it take much time. So that's why they have in between that CPU and RAM, they have a cache. The temporarily save that data, data and information which are need for that to current process. Synchronizing speed, yes, very good. That good answer. Synchronize the speed of that RAM and CPU. Yeah. The memory cache speed the process and the computer because it store the frequently and instructions frequently use the instructions and data. So processor here you can see L1, L2, and RAM is there, and there's L3 also. But here you can see that the slower access than the L1, L2. L3 is very slower. What is the speed fasted one? L1. Then L2. This L1, L2 are in that processor chip. In between, they have a some architecture. You can see that the L3 is in the separate, not including that CPU chip. So if you use this kind of chip, so that motherboard will be expensive definitely. Okay, memory speed. Access time of that amount of the time is taken to processor to read from that memory. That is the call that the memory speed. Access time of the amount of time it taken by the processor to read the data from memory, measured in the nanosecond. Here, millisecond, Millisecond is like 1,000 of the second. Here you can get the idea about that. Nanosecond, 1 billionth of the seconds. Picoseconds. So here you can see when you want to blink your eye, it is like a 10 million operation time. So that means one blinking time that your eye lives, it is similar to the 10 millions operations can do in that processor. Okay, so then you can imagine what kind of speed in there. So now we will move to that secondary memory, sequential and direct. I am not repeating these things. I think you already got these things in that your A-level syllabus and not much important. Sequential. Sequential means we have to read like one after another. You cannot read directly that one particular point. Sequence. It can go to direct, but it takes time. You know that a cassette record, cassette tape, if you want to listen that some music or miss the song in that middle, you have to check the second one pass, third one pass. So you have to forward and stop and play, forward, stop and play, like that. So you cannot directly access. But when you want to listen that music in that your CD, you can see that list. When you click that song name, you can run simply. Okay, so it is direct. This is sequence. Individual blocks and have the unique address in the direct. The access by the jumping to the block pulse sequential search. Access time depend on the location and previous location, but much faster than the sequential. And what's that mean? Even in that disk, they have block address. They have unique address for that each block, even though it takes time based on that current location and the previous location and the new location when you want to move. Okay. External memory type, hard disk, magnetic disk, solid state disk, SSD, but in here not the SSD. Okay, optical, CD-ROM, CD rewrite, recordable, CD rewrite, DVD, magnetic tapes, and when you talk about the here you can see that SSD. This is a new technique, very fast, very expensive, and they have a much density to keep that more data. The hard disk, I also call that a hard disk drive, SSD, contain one or more inflexible. Why mean that more inflexible means it take time. Circular platter that are magnetic particles to store data, instructions and information. SSD, solid state drive, is a solid state storage device that is used at integrated circuit assemblies in that to store the data in persistently. SSD replace traditional mechanism that a hard disk by using that flash based memory. Actually, SSD have that this technique, flash drive techniques, and significantly faster. Typically using that flash memory and functions are secondary storage in that hierarchy of that computer storage, so that it is a little bit similar technique using that flash. So I will ask that this kind of thing, what is the difference between that SSD and SSD? Yes, so here you can see that how much they change that capacity. I think we are almost listen that a terabyte, but petabyte, and these are used normally who are using that massive data. As example, NASA. So weather forecasting, they are using this kind of things, and those servers, they use that kind of memories because the servers are give that space for users. So then we will move that function of that IO module. IO module, input output module. Here you can see the address or links come from that main memory or the CPU. Inside that the CPU, address line, data line, what is that? Control line. Each and every line send the different data. Yeah, address line definitely send at the location where we want to access. Data line send the data. Control line is say that the CPU send that read this data from this cell. Okay, the control line. It is give that open, no, close that particular line cells. Control and timing, CPU communicating, device communicating, data buffering. Here is a data buffer also, error detection. So I will ask, what are the main functions in that IO module? IO module is control all input-output device according to the given instructions by the CPU. Okay, IO module is control the input-output device. Okay, so what are these control? Control and timing. They are considered the timing. And because now you think one process use the two different or many different output device. As example, now I am presenting that this presentation that what are the input-output device. Speaker is working and microphone is working and display is working and keyboards is working, everything is working. Okay, work together. So then they want to control the time. Which one you give that high priority? Okay, so then they are controlling the time and CPU communicating with that each and every device. Device communication, device to device, they are communicating. And data buffer. Data buffer is why using that data buffer in here. The reason is external device or input device are their data processing, data transactions time is very slow. So then they have to keep temporary data in this inside here. So because the RAM or CPU are access data faster than the external device. So then they want to keep the data in that buffer. Buffer is like a register. Registers are kind of like a cache, little bit speed, not a little bit, much more than the RAM speed up. So then they are keeping the data in temporary. I will ask that what's the mean buffer, data buffer, error detections, and also IO module is always try to send. I think you will notice this kind of that when you log in that your computer. Sometimes you will see that your taskbar like triangle colored like yellow and giving that explanation mark. They are showing that some error. And also when you go to that when you want to check that your computer is working or not, so when you go and check that your status of that computer, it is say that explanation mark, that red like a triangle is a yellow color, something like. So that means IO module is always try to detect the errors. When you find that error, they will give that this kind of thing. Yes. Pawan is in that mark of that warning. Yes. So keep in mind, I will ask what are the main functions done by or handled by the IO module. And I will tell, please explain two of them. This kind of question may be in your paper. So very simple. You have to study. Keep in mind. So very interesting. Just think and why they are using the data buffer. What does the mean error detection? Likewise, no need to no need be like a parrot to keep in these things. Okay, katapadam karang onna, just get the idea about what is the purpose. So then we are moved to that the buses. Buses is communicating with each and every devices. The buses are communication pathway connecting two or more device, share the transmission medium, shared transmission medium with only one transmission at a time. That means at one time they are transmission particular data. The number of channel in the bus, it is important. They have a we are asking, but what is the width of the bus width? That means how many channel available in there. It is interpret how many data can be sent at once. Here 32-bit data bus means at once it is sent the 32-bit value. So that means 32-bit data bus means they have separate 32 lines, channels. Okay. Bus interconnections. Computer may have different buses for the various purpose. There may be separated or categorized in the three types: data bus, address bus, control bus. I think we show that here. Address bus, data bus, control bus. Now, I think you can get, you know now that the brief idea about that. Why is the data, why is the address and control. Beside the power distribution line, for the supply for the power to attach a module, beside the, so other than that, they have some like power distribution like similar with that bus, but different technique they are using and they are not sending the data. Okay, data bus, data line, they are path of the transfer data. Data bus much consists that 8-bit, 16, 32 separate line carries a data. Remember that there is no difference between the data and instruction at this level. At this level, while they are transferring here to and there, they are not concerned that differently. They all are concerned at similarly like a data and instruction. But when you receive that this thing through that CPU know is this is a instruction, this is a data. Okay. Which is a key determination of the performance here. So when you want to buy that motherboard, you should know that what is the bus speed. But if it is not compatible with that CPU and then memory, so you cannot get that high performance, that expected performance. Address bus. Identify the source of destination address of that data in memory, memory or data. So in here, memory means definitely they are talking about the primary memory, that means RAM. Data in memory, RAM. Okay, and IO module. Example: CPU need to read the instructions or data from the given location in the memory. So then they should know that address where the data is available. Bus width determine the addressable memory locations. So that means bus width is depend on that addressable memory locations. Addressable memory location. What's that mean? So we will learn that 8080 has 16-bit address bus. Give 64K address space. What's that mean? Now it is say that that 8080 architecture, computer architecture of that 8080 has a 16-bit address bus, and it is give the 64K address space. What's that mean? Can you calculate it? How it is